Inhaled smoke containing nicotine rapidly travels through the trachea and navigates through the increasingly smaller branches of the bronchi to terminate in the alveoli. Nicotine traverses the alveolar and capillary membrane, entering the bloodstream. Traveling through the circulatory system, nicotine completes its journey to the midbrain within 10 seconds of inhalation. Nicotine acts in the mesolimbic dopamine system, specifically the ventral tegmental area, VTA. Entering the VTA, we see nicotine binding to the alpha-4 beta-2 nicotinic acetylcholine receptors. These receptors are located on the surface of both the nerve cell bodies and near the terminal end of the axon. Binding of nicotine leads to activation of these nicotinic acetylcholine receptors via a conformational change and allows for ion exchange. As we peer down the inactive receptor, we see that the channel is closed. Once the binding sites are occupied, the channel is activated. The gate opens and ion exchange begins, allowing for the depolarization of the neuron, resulting in an action potential. The action potential travels from the VTA to the terminal end of the axon, located in the nucleus accumbens. As the neuron is depolarized, the neurotransmitter dopamine from the vesicle within the presynaptic bulb of the terminal axon floods the synaptic cleft. This is believed to initiate the reward response that is associated with smoking. Because nicotine's effect is short-lived and levels quickly decrease, dopamine levels decline at a rapid rate as well. This process is what eventually leads to the craving for more nicotine. Each time nicotine enters the system, dopamine levels surge. However, with prolonged smoking, a tolerance to nicotine will develop. This tolerance is a result of nicotinic acetylcholine receptors being upregulated and becoming desensitized to nicotine. Focusing in on the ventral tegmental area, we observe Chantix, varenicline, binding to the alpha-4 beta-2 nicotinic acetylcholine receptor on the nerve cell surface. However, unlike nicotine, which is a full agonist, varenicline was deliberately designed as a partial agonist, highly selective for the alpha-4 beta-2 nicotinic receptor. Varenicline is believed to partially stimulate these receptors, and in the presence of nicotine, varenicline competitively binds to these receptors and blocks the ability of nicotine to activate them. This higher binding affinity of varenicline for the alpha-4 beta-2 nicotinic receptor supports its antagonistic property. As varenicline binds, there are fewer available binding sites for nicotine. This result and the agonist effect have important implications for the mesolimbic dopamine system. Due to the decrease in nicotine binding and the partial stimulation by varenicline, there is a marked reduction in action potentials from the VTA leading to the nucleus accumbens. Although varenicline is believed to also affect the same alpha-4 beta-2 nicotinic receptors that nicotine activates, the stimulation of neurons by varenicline in this area of the mesolimbic dopamine system results in a lower dopamine release than that caused by nicotine at the synaptic cleft in the nucleus accumbens. Again, varenicline acts by partially stimulating the alpha-4 beta-2 receptors in addition to preventing nicotine from binding. Chantix is a unique partial agonist selective for the alpha-4 beta-2 nicotinic acetylcholine receptor that has been approved as an aid to smoking cessation treatment in adults. The most common adverse events associated with Chantix were nausea, sleep disturbance, constipation, flatulence, and vomiting. Nausea was reported by approximately 30% of subjects treated with Chantix 1 mg BID, with approximately 3% discontinuation rate during 12 weeks of treatment.